Good afternoon, students. Today I will discuss some numerical problems related to the electromagnetic induction. Okay, so let us begin. So, coming to the first question. Two coils C1 and C2 have N1 and N2 turns respectively. Current I1 in coil C1 is changing with time. The EMF of C2 is given by, so there are four options are there. That is, first one is di1 dt minus di1 dt. Option B is minus m di1 dt. Option C is minus m di2 dt, and D is minus m di1 square dt. Okay, so let us solve this question first. So we all know that N2 phi 2 is directly proportional to I1. So therefore we can write N2 phi 2, that is equals to M I1. M is the mutual inductance. Therefore E2 equals to minus N2 d phi 2 dt. That is basically what is phi. Phi is basically, you can write it as basically N2 is being introduced within the derivatives, that is dt. Next one is that E2 equals to minus N2 phi 2 is nothing but Mi1, right? So it will be m of di1 by dt. So this is the answer for the question number 1. So here, from here, that is, this is I1. So from here the option B is correct. Okay. So coming to the next question. A pair of adjacent coil has a mutual inductance of 1.5 Henry. If the current in one coil changes from 0 to 20 ampere in 0.5 second, change in flux linked with, so the options are there 35, 45, 30 and 40. So let it do. So change in flux, that is del phi, is known as, this is mutual inductance already given, that is 1.5, and change of current is 20. So therefore the answer is 30 Weber. Hopefully it is clear to all. So the option C is correct. Now coming to the next question. The magnetic field between the horizontal poles of an electromagnet is uniform at any time, but its magnitude is increasing at the rate of 0.020 Tesla per second. The area of the horizontal conducting loop in the magnetic field is 120 centimeter square, and the total circuit resistance including the meter is 5 ohm. Now induced EMF and the induced current in the circuit are. So there are again four options are there. So let it do this. Okay. Basically we know that E, that is basically rate of change in magnetic field into area, right? So therefore rate of change in magnetic field that is defined as 0.020 into 120 into 10 to the power minus 4. So it becomes 0.24 millivolt. So what is I? I is nothing but E by R, right? So what is E? Already we got, that is 0.24, and R is already given as 5 ohm. So the answer will be 0.48 milliampere. So the options, that is, wait one second, 0. Let me check once. Sorry, 0.048. So the option C is correct. Okay. Next, coming to the next question. When current changes from plus 2 ampere to minus 2 in 0.05 second, an EMF of 8 volt is induced in a coil. The coefficient of self-inductance of the coil. There are 4 options: 0.8 Henry, 0.1 Henry, 0.2 Henry and 0.4 Henry. So let us do this numerical. Okay. So basically we know that self-induction L equals to minus E by change in current with respect to time, right? So therefore change in current, that is equals to E by L. What is E? E is already given, that is 4, and L is also given, that is 0.05. That is basically minus 80. E equals to 8 volt. So therefore L equals to minus L of minus 80, that is basically 1 by 0 Henry, 1 by 10 Henry, that is basically 0.1 Henry. So this will be the answer for the question number 4, 0.1, option B. Now coming to the question number 5. What it is saying? A toroidal solenoid with an air core has an average radius of 0.15 meter. Area of cross section is 12 into 10 to the minus 4 meter square and 1200 turns. Obtain the self-inductance of the toroid. Ignore the field variation across the cross section of the toroid. So let us do this numerical. So according to the problem, radius is given, that is R equals to 0.15 meter. Cross sectional area A is given as 12 into 10 to the power minus 4 meter square. Number of turns, that is N equal to 1200. Okay. So magnetic field B is given as mu 0 N 1 into L, that is mu 0 n1 L by L if I write. So basically mu 0 n1 L. What is L? L is the, as we are considering toroid, so it has a circle. So what is the total length? That is nothing but the perimeter, right? So that is 2 pi r. So magnetic flux is, that is phi, that is n1 BA. Already B we know, that is mu 0 n1 square LA by 2 pi r. Right. Also we know that phi b equals to basically L into I. Right. So L, therefore L equals to phi by I. Right. So L will be mu 0 n I square A by 2 pi r. So if you put the values in general, you will got the result as 2.3 millihenry. So this is the answer for the question number 5. Hopefully it is clear to all. In the next part, I will continue with the rest of the theory part. Thank you.